Hello students, today we will see the topics 2-pass assembler, advanced assembler directives and the topic that is pass 1 of assembler. So first of all we will study what is 2-pass assembler. In the previous lecture we studied the concept that is called as forward reference problem. This particular 2-pass assembler is also going to handle the problem of forward reference easily. In the first pass, location counter processing is performed and the symbol declared are added to the symbol table. We know the structure of symbol table, which consisting of the symbol and corresponding addresses in this particular data structure. The second pass construct the target code using the addresses those found in the symbol table. So we will see what the pass 1 does. It performs the analysis phase. The first step that it performs that it is going to separate the symbol, mnemonic opcode and operands from the instruction. Then it will validate the opcode with the help of the mnemonic table or the opcode table. After this, it will build the symbol table and the literal table. Then it will perform the location counter processing and at the last, it will construct the intermediate code. So these are the number of tasks those are performed by the pass 1 of 2-pass assembler. Now we will see what is the task that is performed by pass 2. It performs the synthesis phase. In the first step, it will get the machine opcode from the opcode table. Then it will get the address of symbol from the symbol table. Then it get the address of literal from the literal table, and at the last it will synthesize or it is going to construct the target code instruction. Now this particular slide going to show you the job that is performed by the 2-pass assembler. So in the first pass we are going to give the input, the source code, that is the assembly language program. The pass 1 takes the help of the opcode table and it will generate the symbol table and the literal table. The output of the pass 1 is it is going to generate the intermediate code, which is the input to the pass 2 of the 2-pass assembler. The pass 2 will get the help of the opcode table, symbol table and literal table, and then it is going to construct the target code. So this is the job of the 2-pass assembler. Now we will see the advanced assembler directives. The first directive is called as origin, with the syntax origin followed by the address specification, where the address specification is an operand specification or some constant. Now we will see some of the examples. The example origin 500 will set the location counter to 500, where we are going to mention the address specification as the constant over here. The next example is origin loop, where the LC set the address of the symbol loop. Next example is origin loop plus 10, where the LC set to the address of loop plus 10. So if the address of loop is 600, then the location counter will set to 610. The second assembler directive is EQU, where the syntax is symbol EQU followed by the address specification. This directive associates the symbol with the address specification, that is the operand specification or the constant. For example, num EQU total. So this statement is going to introduce the symbol num to represent the operand total. The num will get the same address of the total because we are going to use over here the assembler directive EQU. The third assembler directive is LTORG. Before this, we studied that the literals are directly used in the operand field of the assembly statement. And the LTORG statement is going to permit a programmer to specify where literals should be placed. So when LTORG statement is encountered in the program, the assembler begins the assignment of address to such literals to whom the addresses are not yet assigned. But by default, the assembler assigns the addresses to literals after the end statement. Now on this slide, I have shown you one program. So the first statement is start 101. This particular statement is going to initialize the location counter to 101. Now the particular statement, which consisting of the literals 1 and 5, will be get added into the literal pool without the addresses while processing these statements. During the analysis of the particular statements from this, that is location counter 101, to this, the location counter will be 108. The symbol loop will be get added in the symbol table with the address of 105. Now, whenever we'll come across the particular assembly directive LTORG, it will search for the previous literals for whom the addresses are not yet assigned. So at this location, the location counter 109 and 110 will be assigned to the literals 1 and 5, which is shown on this in this particular table, that is a literal table. So I think all of you got the concept how the particular addresses 109 and 110 will be get assigned to the literals 1 and 5. I will repeat again. Here we come across with the particular statement LTORG, which is one of the assembler directive. It will search for the previous literals for whom the addresses are not yet assigned, and over here it will assign the particular addresses to these number of literals one by one. And because of this, we will see the particular literals and addresses over here like this. Now a new literal pool is now started. The literals 2 and 10 specified in these particular statements are added in the next 3 entries of the literal table as shown over here. The assembler assigns the addresses 111, 112 and 113 to these next statements. Now over here, the EQU directives is going to add the symbol again in the symbol table with the address of loop. Just see over here. As we know that the particular loop, it is a symbol having the address of 105, and because of this statement, that is again equals loop, means the particular new symbol again will get the address of the loop, and the address of loop is over here, it is 105, and because of this we are going to assign the address of 105 to this symbol again. Now the next symbol A, B and R are added to the symbol table with the addresses 114, 115 and 116 respectively. While processing the particular end statement, the literals, that is 2 and 10, don't have the addresses yet that will be assigned by the assembler, will get the corresponding addresses as 117 and 118. Because by default the particular assembler is going to assign the addresses to the literal after the end statement. So according to this, the location counter 117 and 118 will be given as the addresses to these two literals. Now I think all of you got the concept of this symbol table, literal table and the pool table. Next we will see the pass 1 of assembler. First pass of 2-pass assembler uses the following data structure. The first data structure it uses is called as optab. It is called as opcode table. It is also called as mnemonic table, which contains the mnemonic opcode, class and the information. The class field indicates whether the opcode is the imperative statement or a declaration statement or an assembler directive. If it is the imperative statement, then it is going to mention the class as the imperative statement. If the particular opcode is declaration statement, then the class will be mentioned as DS. And if the particular opcode is the assembler directive, then it will mention the class as AD, that is assembler directive. If an imperative, the information field contains the pair, machine code and length. Otherwise, it contains the routine ID to handle the declaration and assembler directive statement. Now, in this particular snapshot of the mnemonic table, the opcode that we are going to mention over here it is add. As we know that it is an imperative statement, so the particular class over here will get the entry as IS, and as I told you that if it is an imperative statement, the information field contains the pair of machine code and the length. So the machine code for the opcode add is 01 and the length is 1. Likewise, the opcode is sub, which is the imperative statement, so the class will become IS and having the machine code as 2 with the length 1. Now, as I told you that if the opcode is a declarative statement, it contains a routine ID to handle the declaration and the assembler directive statement. So, if it is a DS, it will be considered as the class DL, and here we are going to mention a particular routine, any routine number which is going to handle the declaration and the assembler directive statement. So over here, the start it is a assembler directive and the particular routine number 11 is going to handle the particular assembler directive statement. And because of this, we are able to build up this particular table, that is mnemonic table, which consisting of opcode, its class and the information. Now the second data structure that the pass 1 of assembler is going to use is the symbol table, which contains the symbol name, address and the length of the symbol. The next data structure it is going to maintain, it is a literal table which contains the literal and the address. And at the last, the data structure pool tab is going to maintain the records of the pools in the literal table. Now, the pass 1 is going to analyze one by one statement of assembly program, and it is going to prepare these data structure using the following steps. Initialize, it is going to initialize the location counter with the value 0. The current pool will become 1 and the literal entry will be 1. Do the following steps while not end statement or the program ends. First of all, we will separate the label, opcode and operands from the statement. If the label present, then it is going to add the label in the symbol table with the address as LC. If the particular opcode is LTORG, then it is going to assign the addresses to all literals from the literal table to the literal table with the entry literal entry -1, and it is going to update the location counter accordingly. If the current pool will get the new value of current pool +1, and it will generate the intermediate code as assembler directive and the code. If the opcode is start or origin, then it is going to initialize the location counter with the value specified in the operand field. As these are the assembler directive, it will generate the intermediate code AD with the corresponding code. If the opcode is EQU, then the address of symbol just added will be the address of symbol specified in the operand field. And as it is the assembler directive, it will generate the intermediate code as AD with the proper code. If the opcode is of declaration statement, then perform the routine ID specified in the op tab. The location counter will become location counter plus the length of from info field of the op tab, and it will generate the intermediate code as DL, code. If the opcode is of imperative statement, then the machine opcode from the op tab will be get initialized, and LC will become the value of LC plus the length from information field from the op tab. If the operand is literal, then add literal into the lit tab with the proper literal entry. The literal entry will be get incremented by 1, and the intermediate code will have the entries IS, code, and the literal with the literal number entry. If the end statement, then it is going to generate the code AD with the proper value. So this is the first pass of 2-pass assembler, which is going to use the particular data structure. Thank you for careful listening.